Welcome to Photons, brought to you by the Chemistry Club of Abilene Christian University. So, thank you. So, whenever we are in the lab, we ask ourselves, if we could play with light, what would we do? So, there are several experiments that are related with light. So, today, we would like to share with you how to have fun with light. Before we show you the experiments, let's define first what a photon is. So, a photon is the particle of light. This particle is very, very small. It contains a lot of energy that is manifested as light. So, you can find these sources of light in the sun, in the spotlights, also in your lanterns, cell phones, and every other source. So every time that you turn on a light, billions of those particles are released. These particles do not move in a linear way. They actually do it in a sinusoidal, as you can see in the back. So whenever these particles move, they don't do it like a baseball. They do it like waves. These waves can go in very slow patterns, but they could also go very, very fast. So these differences in the waves is what allows us to see different colors. These photons can also be found in fire, in lasers, and also in chemiluminescence, which are the experiments that we will show you today. So now let's see the first experiment, Genie in a bottle, which is related to fire.
Hi, my name is Claire Schutte. I'm a junior chemistry major here at ACU. And so this is my friend Allie. She's also a senior chemistry major. And we're going to talk about fire. So we know that when we go to pump gas, we're not supposed to light matches. Why is that? That's because the vapor of something that's explosive, when it's highly concentrated, can also be explosive, not just the liquid itself. So in each of these bottles, we have put some alcohol. We've allowed it to evaporate, and it's highly concentrated in these jugs. So let's see what happens when we light them.
And if y'all notice, the middle one was a little more green than the other two, and that is due to different metals. So fireworks also work with this way. So you see like the red fireworks, the green fireworks, the blue ones. That is due to the different metals that are in the composition of firework and the different metals of the solutions that we put in each jug.
So I'm Tyler. I'm a junior biochemistry major. And so first off, I wanted to ask for audience participation with this question. Raise your hand if you have seen somebody in action using a laser. All right, that's like 50%. That's pretty good. But surprisingly, that it should be the majority of the room, a large majority of the room, that has seen a laser in action, because lasers are actually used in things like barcode scanners. They're also used for welding, as well as for things like laser eye surgery. But I've always wondered what happens when a laser interacts with a balloon. So Stephen, can you tell me about that?
Of course. So here I have a pretty high-powered laser. You can kind of see it right here. Not the kind of laser that you want shooting in your eye. So we know that lasers are a form of energy. And when we point it at things, well, it does certain stuff. So, to put it simply, so what happens if I point this laser at a white balloon? Nothing. That's supposed to happen, because white reflects light. Now, pretty obvious. So what would happen, though, if we change the color of the balloon? should be popping. Over here. Wow, they are not popping. But usually, if this were a higher powered laser, it works, that's science for you. It works every time, but when you don't want it to. But usually, so black usually absorbs light. We know that because we live in Texas, and if you touch a black car, it absorbs energy. So as I'm pointing this laser at this balloon, what it's doing is it's absorbing energy. And, hopefully, what it would do is that it would absorb the energy, causing the balloon to pop. Now, these balloons just not cooperating, but that's okay. So, we know that lasers do other things that I'm about to show you right now. So right here, we have tonic water, and in this one we have regular water, and we're going to fill this up real quick. Now we're going to see in a little bit how lasers are going to affect the water.
I know you all came here to watch us pour water today, so thank you.
A little more. So this time I'm going to be using a different laser. So this is a UV laser, and it has UV light. Now, when we put it in the water, let's see what happens. Nothing happens. But when we put in tonic water, you see that? So the reason why it fluoresces blue is because tonic water has a compound called quinine. And what this quinine does, it's kind of like a little kid on Christmas morning. It gets super, super excited. And when it gets super excited, it gives off this blue color. Now, I'm going to add a fluorescence to this water. See, I'm going to stir it up a little bit. And this time it's going to fluoresce yellow. Now, why does it fluoresce yellow? So it fluoresces blue in here because quinine has different properties to giving it that color. But rhodamine gives it a different absorbance, and it gives off yellow. So it's really kind of cool when you put them together. Let's see. See, it kind of gives us that. There we go. So what these lasers are doing, so what makes lasers so useful is that we can use them for a variety of substances. So like with laser eye surgery or with barcode scanners, the different properties of lasers give us that ability to do different things with them, as shown by this experiment. So we're going to move on to our next and last experiment.
All right, my name is Balkato. Our final experiment is called Chemiluminescence. This reaction is really simple. We have a solution of hydrogen peroxide, and then a solution containing mostly a substance called luminol. Basically, when you combine these two, it'll produce light. Essentially, this reaction is basically when two friends who haven't seen each other in a long, long time come together and get super excited. When they meet, this excitement is so big that they actually release energy in the form of light, as we're about to demonstrate. So that's chemiluminescence.
Now, before we go, we have a little surprise for you, and we just as a thank you so much for listening to us.